Right. Okay. That is right. Okay. Now we will practice. Right. The questions based on the atoms. Right. Um, Here we first look at we'll see whether we can read the atomic symbol, the notation. If I consider an atom like this, N. So this is whatever given on the top. Okay. That is the mass number. On the signal, on the bottom, we'll have the atomic number. Mass number equals to the number of protons and the number of neutrons in the atom. Okay, so that's the total of proton plus the neutron equals to the mass number. The atomic number in a neutral atom. Okay, in a atomic number equals to the number of protons in a neutral atom. Yeah. So in a neutral atom, okay, that's equals to the number of proton. So the number of protons will be equal to the number of electrons for in a neutral atom. Okay. So that will be equal to the number of electrons in a neutral atom. Why? Because I cannot generalize it always. So number of protons equals to the number of electrons. No, I cannot generalize that because when it forms into an ion that can accept the electrons or it can donate the electrons out. So the electrons will not be equal in a ion as well as in O to its previous neutral atom. So when you say the protons, number of protons in atomic number equals to the number of electrons, yes, that happens only in a neutral atom. So when you are reading the statement questions or true and false questions, you should read these statements very carefully. Right. Here, we'll look at these. We are given the different atoms and we have to complete this step. Right. Look at the first one, xenon. Is given the mass number is 131. The atomic number is 54. So what is the number of protons? It's a very straightforward question. So atomic number equals to the number of protons and that will be equals to the 54, right? 54. And number of neutrons. Okay, how we can get the number of neutrons? So the mass number equals to the total protons plus neutrons. So then this should be 130. 131 minus 54 equals 77. Right. Number of electrons. Number of electrons will equal to the number of protons in a neutral atom. So therefore number of electrons will be also 54. Right. The period number. Do you know that? Do you memorize that? No. You will be given a copy of the periodic table. So you should be able to locate this xenon, SXE, in the periodic table. Then you will find out it is given in the period number 5 and the group number will be 18O8A. It is inside, it is in given in the noble gases, inert gases column. So what is the isotope name? Isotope name will be xenon 131. Oops. Mm, right. Okay. Nice. Any questions?
Yeah. Uh, what on the periodic table indicates the period number?
The rows.
Okay, okay. So it's on row 5. Okay,
Yes. Yeah.
okay.
Yeah. I'm sorry. Yeah. Thank you so much for bringing that into the to my attention. Yes. The period is the row number. The
Okay.
group is the column.
Thank you.
You're welcome. Any other questions? Okay, then we'll go to the next one. Right. Now we are not given the symbol. We are given the number of protons, number of neutrons. Right. Since this is a neutral atom, the number of protons will be equal to the number of the electrons. So that will be equal to the 30. Mm, right. And the in a periodic table, when you, okay, this is very important. In a periodic table, when you are going to look for an unknown element, will you choose the mass number or the atomic number? Yes, what do you
Atomic
think?
number.
Yes,
Atomic
you
number.
must, yeah, you must use the atomic number. Why we cannot use the mass number?
Because it's the weight of the element and not the identifier.
Um, That's not exactly the answer, but I think you know what was it? Because for a one element that can it can have different atomic masses. Why? There is some concept called isotopes. So as an example, for chlorine, if I take the chlorine, it can have 35 chlorine or 37 chlorine. Why? Those two, just the same element, but they can have though some atoms can have these 17 neutrons, the other portions of the chlorine atoms may can have 19 neutrons. Okay, so when they can have, just for the same element, some atoms can have the different number of neutrons. So when you are going to look for an unknown element in a periodic table, you always stay with the atomic number. Not, you shouldn't go look for the mass number. Right. Is it clear? Right. So then when you go check this, the atomic number in the periodic table, you will see that was for the zinc. And you will read that from the periodic table, the mass number as 65 and the atomic number as 30. Okay. Then you will see it is in the row number 4. So we can say it is in the period number 4. Right. And when you look for the group, you'll go check the column. So it is in the column number 12 or the group number 12, or can be given as 2B, because it is included in the transition metal ions. Right. The isotope, what can be the isotope for the zinc? It is zinc 65. Right. So this is the isotope 65. Okay, we calculated that for the 65 because we were given that the number of neutrons as 35. So 35 plus 30 equals to 65. That's why we gave it as this isotope as zinc 65. Is it clear?
Yes. So when you were going over the different isotopes for chlorine,
Mm.
would that also change, like, so chlorine 35 and then chlorine 37?
Mm-hmm. Yeah.
Okay.
So, yeah, that's a good question. You'll check whether, depends on the mass number, you'll define which isotope that you had with this question. Okay. Right. The next one. We were given that the number of neutrons as 12 and number of electrons as 10. How could we find the number of protons in here? The situation is very like we have a very good situation here, since we are looking for neutral atoms. In a neutral atom, number of electrons are equal to the number of protons, so we can simply fill that row as 10. Right. So then you look for the periodic table for this number 10, the atomic number 10. So then you will see it as neon, atomic number 10. And what must be the mass number? So we'll add the number of neutrons and the number of protons. It is 22. Right. It is 22. Mm, give me a second. Right. Okay. So now, when you go to look for that one, you will find it as it is located in the row number 2, and the group number should be in uh, 18 as well. It is in the this Nobel gases. It is under the Nobel gases, right? And the isotope name will be neon 22, right? Okay, the isotope should be given with the um, mass number, right? Let me get a different color to work on with the ions, right? Now we'll look for the ions. Okay, let me clean this. Right. Okay. Now we have Fe2 plus ions. So number of protons. When an atom change to an ion, can it change the number of protons? Where those protons are located? If this is the atom, okay, here is the nucleus, right? Inside the nucleus, we have protons plus neutrons, and outside, the outside this the on the in the valence shells or in the energy levels, the electrons are located. So when an ion is formed, the electrons will be lost from these outside energy levels. um, O electrons will be added to these the outside energy levels. So what I was trying to say is, when an atom is changed to an ion, only the number of electrons will change. It cannot change the number of protons or neutrons. So here the mass number and the atomic number was given. So I would say even in the iron, when it forming into 2 plus iron, still the number of protons will be equal to 26. And what must be the value for the number of neutrons? It will be 56. Uh, why? Mhm. 56 minus 26 will be equal to 30. Right. And number of electrons. Okay, now it has 2 plus charges. What does that mean? How can we make a positive ion? The positive ion will be made by losing electrons. Okay, so it has more protons. To a positive ion means it has more protons than electrons. So how many? Like how many extras? Two extras. So we had how many electrons then had been lost? Yes, two electrons should be lost. So the total was the we started with in the neutral atom we had 26 but has lost only 2. So now the electrons must be 24. Right. When you look at the periodic table, you will find it is located in the period 4 and the group number will be 8. Oh, oh. Mhm. This is a brand new iPad. It doesn't take my the it's still figuring out. Okay. So the period number is sorry. The group number is 8 or 8B. Oh, come on. Okay. 8. B. Right. So we'll write the isotope as iron 56. Right. Next one. We are given the number of the protons, number of the neutrons, and number of electrons. Right. When we trying to locate the element in the periodic table, do we look at the number of electrons? No. We'll look at the number of protons, and that is the atomic number, and you will find it as the phosphorus. Okay, the oh sorry, that's the I have we'll look at the number of protons 15, so that's the phosphorus, the 32 and 15. How did I get the 32? I added the 15 plus 17, right? So the period number is 3. Oh, okay, iron. What is the iron? This is not a neutral ion. So look, let's compare these, the protons and electrons, right? What is in extra? Yes, we have more electrons than the protons. How many more? 3, right? So this must be an anion or negatively charged ion, not a positively charged ion. Why? We have more electrons in it. How many more electrons? 18 minus 15. So it is 3 minus. Okay, we have 3 electrons more than the number of protons. So it gives, you have, if you remember the charge of the electron is a -1. If you remember the charge of the proton, so we gave it as +1. What is the charge of the neutron? It is 0. Yes, you are correct. Okay, so the group number for this, the phosphorus is the 15. Okay, let me select that. 15O5A, and we can write the isotope as phosphorus 32. Okay, you have any questions for me?
So when the ion is negative, we will add, and then when the ion is given as a positive, we will subtract.
Correct. Very good. Yes, that's right. When you are forming a positive charge, you are losing electrons. When you are making a negatively charged ion, you will gain the electrons. Yes, that's right. Okay. Now, the next question. We are calculating the average atomic mass. I'm not sure we have done that in, I think it was discussed in the videos. Okay, right. So here, look at these values. The We have 64.88 percentage with this mass, 16.22 percentage of that mass, and 18.90% with this mass. So what is the average one? So we'll add all these things together with their relevance abundance. 55. Oops. 55.9869 times 6. Okay, the percentage, you divide that by 100, or you can just say it like 64 times 88 divide by 100. And what is that number? And then that will be 36 point. Okay, you'll write whatever you see from your will be displayed in your calculator. 36.32 4. Come on. Oh, I'm sorry, trying to figure out that. Right. 324.3072 AMU atomic mass units. The next 57.9865. Okay, I'm sorry, I just forgot to add the units in there in previous one. AMU times the 16.22 divided by 100, so that will be equal to 9.4054103 AMU, and then 58.9838 AMU multiplied by 18.90 divided by 100 equals to 11.1479 AMU. And when you add, then next you will add all these three things, now three answers together, to get the average mm, mass for this one. Oh, oh. It will be 56.876492 AMU. Right. So this is an addition. When how many decimal places were given there? Um, the okay, when we got this the multiplication and the final answer should be given with the four significant figures. So the answer will be given with 56.88 AMU. Right. Questions? Okay. If not, I will go to the next one. Right. Here we are trying to do the conversions. This is a very important part of this the course. We'll work with the moles and grams. Right. So what is a mole? The one mole contains how many things? Mm, One mole has how many things? 6.023 times 10 to the 23rd things, right? If, like, as an example, right, if you say dozen, okay, give me a dozen of donuts, you know that you will get 12, right? Like that. One mole means it has this many things. That's a mole, okay? So the mass of the mole is, okay, if I said what is the mass of oxygen, so how many oxygens are in there now? Yes, 6.023 times 10 to the 23rd things are in one mole, and the mass of that means the mass of this many atoms of the oxygen. Right. I think I was okay. I just wanted to give you a brief explanation on mole and the molar mass. Right. Let's go to the problem now. How many grams are in 15.0 moles of the following elements? Sodium, right. So the symbol of the sodium, you should be able to read that from the periodic table. It is Na, right. We'll start with the unit with the parameter given with this question. It is moles. So we'll get this 15 15.0 moles. Right. Okay, then denominator. What must be in the denominator? 1 mole, right? 1 mole of sodium. And this is 15.0 moles. Let me correct that here. 15.0 sodium moles. And this is a 1 mole of sodium. What is the mass of 1 mole of sodium? We are trying to find the grams, right? Mass. So 1 mole of sodium. So you will get the molar mass of the sodium, atomic mass from the sodium. You will read it from the periodic table. So there you will see 22.99 grams. So then the moles to moles will cancel out, and we'll get the answer in the grams. It will be equals to 344.85 grams. So we are given the problem with three significant figures. So we'll round it to the third significant figure. So that number is greater than 5. So we'll add a 1 to the 4. So that will be 345 grams. Right. And you can put a decimal place there too. Exactly. Right. Iron, 15 moles of iron. The next question. 15 15.0 iron moles multiplied by the 1 mole of iron equals, read the mass from the periodic table, that will be equal to 55.85 grams of iron. So moles to moles will cancel out and we'll get the answer in grams. And that will be equal to 837.75 grams. And again, the answer should be given with three significant figures. So this number is greater than 5. Therefore, we should add an plus 1 to the 7. So the answer should be 838. You can put the decimal place, and that is the final answer. Right. Do you have any questions? Right. Next, we'll go to the conversions between atoms and moles. Right. So as I have started with, the 1 mole has 6.0.22 times 10 to the 23rd atoms in 1 mole. So in platinum, right, we'll get this 15.0 mole of that, okay, and will contain, okay, 1 mole contain 6.022 times 10 to the 23rd atoms, and that will be equal to 9.033 to 1 times 10 to the 24. So we'll round it to the biggest, to the third significant figure, that will be 9.03 times 10 to the 24th atoms. Right. Do you think that I would get a different number if I even calculated that for the sulfur, if the moles are equal? No, I will get the same number since 1 mole is always has 6.022 times 10 to the 23rd of atoms. Right. Questions. Right. Now, the next question. How many atoms are there in 2.58 grams of cobalt? Now we are changing grams to the atoms. So what is our the in between the unit the factor? We must have that the Avogadro number, or the 6.22 times 10 to the 23rd. Right. So we'll start with the uh, grams that was given, okay, 12 point. We'll find the number of moles in the 12.58 grams of cobalt first, right? Okay. um, we'll start with the 12.58 grams of cobalt multiplied by, okay, so then um, 1 mole equals to the, oh, what is the molar mass of cobalt? Yes, that is 58.0 1.93 grams of cobalt. Right. So then the grams to grams will cancel out. Uh, right. Next, we'll change the, now we change the moles into the atoms. 1 mole of cobalt has or equals to 6.022 times 10 to the 23rd of atoms. So that will be equal to the 1.28 if I put the everything that I obtained from the calculator, that would be that. But the final answer should have only four significant figures. So then here is the fourth significant figure, and this is number 5. Okay, so that's exactly the 5. So then we'll look at the number after 5. It is less than 4. So we don't do anything. So it will be given as 1.285 times 10 to the 23rd atoms. Right. Do you have any questions? Okay, now the next question is exactly the opposite of the previous question. We are now starting with the atoms and find the grams. Right. So we'll start with the number given. It is 1.887 times 10 to the 15th atoms of carbon. Right. So, what is the relationship between atoms? Next, yes, the known relationship should be the atoms and the moles, right? So, we'll take the Avogadro number 6.022 times 10 to the 23rd of carbon atoms equals to the 1 mole of carbon, right? So, then we'll know that atoms of the carbons and the atoms of the carbon will cancel out. Right. Next, now we change the moles into the grams. We'll take the moles into the denominator. 1 mole of carbon weighs 12.01 grams. Then we'll see that the moles of the carbon to moles of carbon will cancel out, and we'll get the final answer in grams. So you'll get the final answer as 3.76 3.76326 times 10 to the uh, negative 8 grams. Right. So we are given the answer with four significant figures. So here is that the fourth one. So the now the it is we have number 2 uh, after that, but it is less than 5. So we'll give the answers 3.763 times 10 to the negative 8 grams. Okay, do you have any questions? Okay, so I know we have run out of our the time. I will um, I'll